Hey there, it's Christian, and here are the answers to your questions. So we have this crate sliding down at a constant speed. Right off the bat, that means that the acceleration is equal to zero. And if the acceleration is equal to zero, that means that all the forces we have here have to add up to zero. How in the world do they do that? Well, remember when you draw your free body diagram, you have three forces, and then we have to get rid of this mg or ignore it by drawing these two other forces that are components. So if I go through and take a look at this, the mg sine of the angle, so this one, is equal to the force of friction. So those two are equal to each other. And then the normal force and mg cosine of the angle are equal to each other. So really, the vector sum is zero. And so it would just sit right in the middle. And that's because it has a constant speed. So E would be your answer. For number 24. So here we've got a 45 kilogram person stepping on a scale in an elevator, and it reads 480 newtons. So when you're in an elevator or when you are weighing yourself at home, you stand on a scale. The scale reads your apparent weight. So this is what you think you weigh. Okay, it's not your actual weight. Your actual weight is your mass times gravity, and it never changes. And it doesn't matter where you are on the earth, your weight will stay the same. Your normal force, though, if you jump on a scale, you'll see that scale go way up and back down. When you are accelerating up, the normal force is bigger than your weight. And so because 480 is bigger than 4 to 41, and your normal force is bigger than your force due to gravity, you have to be accelerating up. So this one we know for sure is correct. In order to figure out whether you are moving up or down, you have to be told that. So because if you're at the bottom floor and you're moving up, this could be true. If you're almost at the bottom floor and going down, this could also be true because your acceleration in both cases is up. So from the given information, we can't tell if the elevator is moving up or down. And they said there could be more than one choice, and that's why both C and E are correct. If we go to number 27, this one is easier than what it appears to be. So you have these three boxes and they're being pulled by one thing. So if you think about maybe the P here is a train, it's going to be really easy to pull just one box, but if I have to pull all three, I have to pull all three. So what I did was I drew a red box around what P has to pull. I drew a blue box around what T1 has to pull if we ignore these two, because that's what you do. And then T2 only has to pull on the 100 newtons because you ignore everything before it. And I realize they're connected, but you start here and say, well, P has to pull everything. T1 only pulls everything behind it, and T2 only pulls everything behind it. So in red, I added up what P pulls, and that's 130. Blue is T1, and T2 is just the 100 newton box. So when you do this, this has got to be 130, okay, is P, so it's the greatest. And then T1 is going to be 120, so it's the next one. And then finally, the one that has the smallest is T2. So we know that T2 is definitely bigger than T1. T1 plus T2, they do not equal P, so that's not right. T2 does not equal P, T1 does not equal P, and T1 is not bigger than T2. So A is your correct answer there. If we move to the last one, this one I'm not real fond of because this is a difficult one to do for a really quick multiple choice. I've got these boxes connected, and this is called a half Atwood's machine. There's no friction, which helps. And so they want to know what's true about the tension in the string. So you have to actually find the tension. So I drew a free body diagram for the 30 Newton box and for the 10 Newton box. And I know that the 30 is going down and the 10 is moving to the right. So the sum of my forces has to be equal to the total mass times acceleration. I have to find that acceleration first. So here's what I did. I started with the m2g since it is pulling everything else, and I subtracted t. So m2g minus t. Then I added the t for this box. And that's equal to the whole thing. So that's m1 plus m2 times the acceleration of the whole thing. Now I can get rid of my t's because they are equal and opposite. And I'm left with this equation, and I solve for a. So that would be 30 newtons for m2g divided by 1 plus 3. How did I get the 1 plus 3? Well, we know that the force due to gravity is equal to the mass times the gravity. And so if our force due to gravity is 10 and gravity is 10, then our mass has got to be 1 here, and the mass has to be 3 here. And I know I used 10 for gravity, but I can do that as long as I'm consistent. So that makes 1 plus 3 on the bottom. 30 divided by 4 is 7.5 meters per second squared. So now I'm going to solve for the tension in this string. So I want to solve it just for this part. When I do that, I get 7.5 newtons. I should have done the one up top because the equation for it is the tension is equal to m1 times the acceleration. So my acceleration was my acceleration is 7.5. So I put that here. The mass of that top box is only 1, so that's also 7.5 newtons. They should be the same. So your answer here is A. The tension has to be less than 30. And that is the end of what you sent me. Thanks.